I'm Anil Kumar. Welcome to my YouTube channel. Let me thank all my viewers and subscribers for participating actively and sharing some brilliant questions. While these days, because of the fractured hand, I'm not really able to participate at the level which I would love to. However, I'll keep posting some videos whenever needed. Now, the question for this video comes from one of our subscribers, Mr. Parker Lee, who wants to understand the concept of addition and subtraction of vectors. Now, here is a very important question from test point of view, and I hope the solution of this will help many of you. So we'll explore sum and difference of vectors, and we'll look into these aspects. When is the sum, magnitude of sum, greater than the magnitude of difference of vectors? When is the magnitude of sum equal to the difference of vectors? And when is it less than? Can the sum be equal to individual sum of the magnitudes? And what is the minimum value of magnitude of sum of two vectors? So let's begin by understanding these two vectors. Let's say we have two vectors A and B. Now, since we have to work with them all along this video, let me just define them first. Let's say this is our vector A, right? And the vector B will take at an angle to A, and let's say this is the vector B. So in all, whenever we want to find angle between the vectors, we basically place one vector and the other vector both with their tails common, correct? So when I put it like this, so now we have these two vectors A and B, and let us say that the angle between them is theta. So we have this vector A here and vector B. Their tails are common, so basically common tails. To find angle between them. Correct. So whenever we say the angle between the two vectors is 30 degrees, the value of theta is 30 degrees. Perfect. Now we'll look into two things, and that is to say what do we mean by sum and what is the meaning of difference, right? So let's see what we mean by sum. We can find sum in two ways. One is we could have a parallelogram or we could have a triangle. Correct. So we have these two vectors. Let me sketch them once again here to figure out the sum. So we have a vector A, right? And then we have the vector B. Now sum is the diagonal of a parallelogram. So we place this vector right here so that we align it with the head, right? And then complete the parallelogram. In that case, the diagonal from the tail to the head final becomes the sum, right? So in this case, what you see here is that this is a vector A and that is the vector B, correct? And this is the angle theta. Do you see that? That's the angle theta. And that becomes A plus B. Perfect. And in this particular case, when we use cosine law, we use this particular angle here, and we'll call this angle as phi. Correct. We call this angle as phi. So if I have to find the sum of two vectors, then the sum of these two vectors A and B will be equal to the magnitude of A plus the magnitude of B. Okay, let me write down the square so that I don't have to write square root, right? So let's write like this: minus 2 times magnitude of A times magnitude of B times cosine of this angle phi, right? So strictly speaking, I could also write this as 180 degrees minus theta. Do you see that? So that is the angle phi, which is actually 180 degrees minus theta. Correct? So that is the sum of the vectors. Now in case you want the difference, then what expression you get? magnitude of A minus magnitude of B whole square will be equals to their sum minus 2 magnitude of A magnitude of B cos of the angle theta itself. So that is the other diagonal, right? So let me show you the difference here. So the difference will be basically, so if I A minus B will be from here, this particular angle. So when I say A minus B, then what really happens is that this B is actually drawn on the other side, correct? B is drawn on the other side. And so we'll draw it here in this direction, A minus B, correct? So A minus B, that means the sum with the negative B, will be in this direction, correct? So basically, we can say it is this vector which is A minus B. A minus B, correct? So for this vector, we have the angle theta in between. Do you get the idea? So A minus B is the other diagonal of the same parallelogram. And that is how they are related. So I hope you're getting some concept. Now with this, let's move forward and answer all our questions, correct? So first, we'll again look into the sum diagram which we had made so that we can make a bigger and a better picture for this. So we'll have two things here. One is the sum. So let us say this is the vector A for us, and then we have the vector B, right? So if I want the sum of these two vectors, I'll place the vector B here, and then the sum will be this particular, right? So that becomes the sum. The angle theta is right there, right? So this angle is, actually speaking, 180 minus theta, correct? And then you get A plus B. And here we know that the magnitude A plus B, let's write down their squares, is equals to magnitude of A square plus magnitude of B square minus 2 times magnitude of A times magnitude of B times cos of this angle, which is 180 minus theta, correct? On the other hand, the difference will be, so this is your sum, right? And now let's try difference here. So for difference, what we will do here is something like that. There are two ways you could do. One is, let's say we have this vector A, right? Now, vector B is given to us in this fashion. So when I do A minus B, that means A minus B, so we have to have a negative of this added, right? So this is A minus B. Do you see that part? So that becomes minus B. So that's the vector A for us. This is the vector B with a negative sign, right? Minus B. And their addition now becomes A minus B. So from here, we landed up that place. And this is what we call A minus B. Perfect. Now clearly, the angle between them is same. So these are two parallel lines. So that is the angle theta. Do you see that? So when you're talking about the difference, in that case, we have magnitude of A minus B is basically equal to absolute value of magnitude of A plus magnitude of B square minus 2 times magnitude of A magnitude of B cos of theta. Perfect. So that is how we can distinguish between the sum and the difference. So I hope this part is absolutely clear. Perfect. Now when you look at this in this particular stage, we find that the sum is greater than the difference, right? So you can see This is much greater than that small arrow. Correct? Now mainly it is in this situation, since the angle theta which we are talking about is an acute angle. So this is the situation for acute angle, when theta is an acute angle. In that case, what we see is that the magnitude of sum is greater than, let me write down, the difference. Is that clear? So you can also compare with the diagram itself. Do you see that? So if the angle theta is an acute angle, in that case the sum is greater than the difference, as you can very clearly see. Perfect. Now let's take the example when the angle is obtuse angle, right? So basically, well, now we have understood the question and we do have an idea when will what be true. So when is the sum of two is greater than the magnitude of the difference? So that is when the angle between vectors is an acute angle. Perfect. So that is when it is greater. Perfect. So that is what we just figured out. Now the other question is, when is that equal? So for equal vectors, let's change the color. Well, let me rewrite. So magnitude of A plus magnitude of B is equal to magnitude of A minus B when theta, the angle, is equal to 90 degrees. Because in that case, we know cos of 90 degrees is equal to 0. Do you see that? So then both are equal, correct? So let's get back to the equations. We know that A plus B will be equal to, let's write squares, right? So magnitude of A square plus magnitude of B square minus 2 magnitude of A magnitude of B cos of 180 degrees minus theta, right? Now when I write cos of 180 degrees minus theta, basically, you know, cos of 180 minus theta is minus cos theta, right? Cos is negative in quadrant 2. You will also write this as magnitude of A square plus magnitude of B square plus 2 times magnitude of A magnitude of B cos of theta. You get the idea, right? So for theta, which is between 0 to 90 degrees, we know that this value is higher. Is that clear? And if cos is 90 degrees, if theta is 90 degrees, this component is 0, right? So if theta equals to 90 degrees, in that case, magnitude of A plus magnitude of B whole square is equal to magnitude of A square plus magnitude of B square, right? Because this part, cos theta part, is 0 because cos theta is 90, so cos of 90 degrees is 0. You get the idea. Now, the equation for A minus B whole square could be written as magnitude of A square plus magnitude of B square minus 2 magnitude of A times magnitude of B times cos of theta, right? Now, If cos theta is 0, you know both are equal to this equation, because that part to be added or subtracted is 0. Correct? Now imagine what happens when theta is in between. So theta can only be in maximum 180 degrees, right? And 90 degrees. When theta is greater, in that case, cos theta is negative, right? Is less than 0, right? So when cos theta becomes negative, this sign will change. So in that case, what will happen? In that case, the magnitude of A plus magnitude of B will become less than the magnitude of A minus B. Does make sense to you? Perfect. So that is the condition. So I hope the condition is absolutely clear, right? Correct? Now let's take the last example where we will talk about when is the magnitude of A equals to sum of the magnitudes of A and B, right? Those were the squares. So what we're talking about here is that we were talking about the squares, mind it, okay? Magnitude squares, correct? Right? So that is the difference between magnitude squares and the magnitudes itself, okay? Right. Now, another thing is, when do we have the same magnitude? Now, to understand this, let's consider sum once again, triangle, to represent sun. Okay. Now, in this particular case, we'll again go with our vectors A and B. So what we notice here is that we have vector A, right? And then we have vector B. And their addition is A plus B. Now in triangle, we know that the sum of two sides is always greater than or equal to the third side. Now here is a critical thing. What I've written here is greater than or equal to. So that means there is a possibility of both being equal. Correct? So in general, A plus B is greater than. But A plus B can be less than sum of A and B, can be equal to sum of A plus B. When? Only when they are along the same line. Do you understand? So let's get back to our question and understand these concepts once again. To show the condition whether the sum and difference, which one is greater, whether they are equal or not, we looked into their squares, right? Sum of squares and individual sums. And we found that A plus B magnitude is equals to A minus B magnitude, provided that the angle theta is equal to 90 degrees. And that basically means we have a rectangle, correct? So that means we have a rectangle. So let me just draw that rectangle kind of a thing using another ink, right? So let's say one vector is like this, right? The other vector is at 90 degrees. Correct? In that case, the diagonal, one diagonal represents the sum, right? And If I do it the other way, then the diagonal which we have will represent the difference, and both are equal. So that is your a plus b, and this is your a minus b, and they are equal, provided they are at right angles. Correct? Some of you can also see it like this, right? So let me make a rectangle, which is easier to appreciate, right? Like this. So the other diagonal is a minus b, and both are equal, right? So that is how you could see. And if this is what happened between the angles, we're talking about this angle, which is 90 degrees. In the first case, when you have that condition, in that case, the parallelogram which you make is kind of like this. Correct? Now that becomes the case, the difference is higher provided that the angle is not acute but obtuse. So if you have a condition like this, and if we have obtuse angle, let's say kind of like this. Do you see this angle here is greater than 90 degrees? And in that case, a plus b is less than a minus b. Is that clear to you? This condition of being same is when we have both the vectors in the same direction. And the last condition is when you have vectors in the opposite direction. Is that clear to you? So once you understand this, then you know how to really understand and appreciate the whole concept of sum and difference of vectors. I hope that makes it absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.